This is Ingo from RA, and today we are going to do a quick introduction to DiagRA X. In about 5 minutes I will show you how to define a source, prepare it for a simulation run, create some worksheets, select some variables and run a short engineering cycle with measurement, calibration and flashing. As you may not be very familiar with measurement and calibration, let me give you some basic information on the engineering process for which DiagRA X was designed. Modern control units are highly parameterizable and can be used in a wide range of systems and sectors. For example, the same ECU could be used to control an engine of a car, a boat or even a lawnmower. Also, control units are not only used in the automotive industry, but also, for example, in forestry and gardening, heating systems, the electrical industry, and many more. In each case, the parameters of a generic ECU must be optimized or calibrated for a specific system, environmental conditions, and requirements. For such an optimization process, you as an engineer need a tooling with which you can measure all the data you need to evaluate the system's current behavior and with which you can calibrate the system's parameters in order to improve it. That is exactly what DiagRA X as a measurement and calibration tool is about. Okay, so let's get to work. I start DiagRA X with a completely empty database. First, I go to the workspace, where all the sources like ECUs and measurement devices are configured. I create a new workspace and herein a new control unit source. In the properties, I select the description file, which defines all the measurement and calibration variables. Below, I select the corresponding hex file as the basic calibration dataset, which I will start calibrating with. Under protocol, I select simulation, which will make it easy to set up visualizers, also without having actual hardware connected. Next, I switch to the experiment tab and create a new experiment. Herein, I create 2 worksheets, one for measurement and one for calibration. Now that I have all the visualizers in place, I assign some variables via the variables manager. For measurement, I take some RAM cells, and for calibration, I want some characteristic maps. That's it. We are ready to go online. Back on the worksheet, I hit the record button. This will start the measurement session as well as a recording. As you can see, incoming values are instantly being displayed in the visualizers. As the worksheet's layout suggests, the visualization can be arranged freely. It is also possible to detach worksheets onto additional windows and display them on different screens, while always automatically scaling them to the given resolution. In order not to lose orientation, you can always find your worksheet via the worksheet overview. And there is much more you can do for measurement and recording. For example, in the event setup, you can define conditions based on measured data, which will trigger certain actions like recordings, CAN message transmissions, or even pausing an oscilloscope for quick analysis of the last couple of seconds. Also very powerful for measurement is the virtual variables feature. With a virtual variable, you can define a mathematical formula for calculating values based on measured values. The calculation is done instantly, and the virtual variable can be used like any other variable in the system, which means it can be visualized, recorded, used within trigger conditions, as well as in formulae of other virtual variables to easily generate also complex analytical data. For post-processing and analysis of recorded data, there is the DiagRA X viewer. When I now stop the recording, I can directly open the recorded MDF file with the DiagRA X viewer. I can even reuse my current worksheet for saving even more time in the setup of the analysis. Of course, the viewer supports all measurement visualizers of DiagRA X out of the box. In the Pro version of the viewer, you can analyze as many MDF files as you want at a time. You can also create further virtual variables for special statistical evaluations. Have a look at our videos on DiagRA X Viewer Pro for more details about measurement analysis. Back in DiagRA X, I'm going to perform a bit of calibration now. For that, I switch to my calibration worksheet. As we just went online, by default and for safety reasons, the ECU is on the reference page. The reference page contains the last flashed calibration dataset and is write protected. To unlock calibration, I must switch to the working page, which is the memory page in the ECU where all the action for calibration takes place. For switching the page, I go to the binary data manager and double-click the working page. Since I switched for the first time since connecting, I must synchronize the pages between DiagRA X on the software side and the ECU on the hardware side. Now I'm all set to go back to the worksheet and change some values. This can be done in several different ways, like with shortcuts for incrementing, typing values or simple calculations, or visually with drag and drop. After I calibrated my parameters successfully, I want to flash the dataset into the reference page. Before the actual flashing, it may be a good idea to review them first. For that, I go to the Compare pages. Here I can compare the values of all the different pages that I may have. I could as well export the changes to DCM for an external review by a colleague if needed. For now I am happy with my changes, so I go back to the binary data manager and flash the hex file of the working page to the ECU. That's it. I hope you enjoyed this quick introduction to DiagRA X. For more videos, news and information about DiagRA X, have a look at our website. Take care and thanks for watching.